3.1 is about measures of center. You've probably already done these for the most part. If you've ever done mean, median, and mode, that's what we're going to do. But we're going to use some notation you maybe haven't used before. So the first measure of center is the mean. And the mean is simply what you would call the average. The average. We have two means that we want to talk about. One is a parameter, goes with a population. One is a statistic that goes with a sample. Let's do the sample one first. The sample mean. We give it this symbol, X with a bar on top, and we call it X bar. So X bar is the average of a sample. Or we're just going to call it the mean from now on, the mean of a sample. How do you calculate average? What do you do when you calculate average? Divided by what? Right. So you're going to add up all the data values in your sample, and you're going to divide by how many values you have in your sample, or what we call the sample size. Okay? The variable X is going to represent the data values, the individual data values. It's a variable, means it can be different numbers or different things, okay? And in this case, we're going to say it's going to represent the different data values in our sample. And the bar across it means the average of that data. So to calculate this mean, we would want to add up all of the x's in our data, and we're going to number them. We're going to say, let's take the first one, add it to the second one, add it to the third one, and we're going to keep going until we get to the end. And let's say, we don't know what the end is yet. It could be any size sample you could think of. We're just going to say n is going to represent how many there are in the sample. So lowercase n is how many data values you have in the sample. So we're going to divide by that n as well, right? So we're going to divide by the sample size, which is n. Lowercase n. And we also use a shorthand for this notation. It's a Greek letter. It's capital sigma. So it looks like a giant E. And that sigma means sum. So sum in mathematics means you add them up. So if I write sigma x, I'm just saying add them all up, add all the x's. So that sigma x is the same as saying add up all your data values. And then divide by n, sample size. So this sigma, it's a capital Greek letter. There's a lowercase sigma we're going to use too. But uppercase sigma for sum, or it just means add all of these things. You don't have to write plus sign a bunch of times. Okay? You just say add them all up. And then the x is data values. And this n is the sample size. You don't need this formula to figure out what the average is, okay? But we're going to use this notation a lot, and I want you to know what it means when we use it coming up. So, let's introduce it now on a simple formula. So we'll get used to using sigma, okay? And little n is sample size and x is data values. Okay? So sample mean is the average of a sample. That means it's a statistic because it's something that we calculate for the sample. If it's a population, it's a parameter. So we have what's called the population mean. So population mean has a different symbol. It's another Greek letter. It's lowercase. It looks like this. And it's called mu. It looks like an M and a U mashed up together. It's like a U with two tails, okay, instead of one tail. So mu is just the exact same calculation except for population. So I'm still going to add up all the data values, and I'm going to divide by capital N, and we're going to use capital N for population size. So for example, here's my sample. So if I compute sample mean, I'm going to call it x bar. I'm going to add up all the data values, divide by how many there are. So it looks like 1 plus 2 is 3, 3 plus 3 is 6, plus 4 is 10, plus 5 is 15. Divided by 5 would be 3. So my sample mean would be 3. The mean is supposed to measure the center of the data set, or the middle. Does it do a good job? In this example, it does. In other examples, it may not. Okay, but this one, it does a good job of finding the center, finding the middle. Okay. Do you have to know the symbols? Yes. You need to know what the symbols mean. You need to know them by sight. Okay. So a problem may say find x bar. It may not say find the mean or find the sample mean. It might just say find x bar. You need to know what to do. Okay. And there might be a question on the test that just tells you to identify the symbols. All right, so you need to know the symbols. Okay? All right. Next measure of center is the median. The median's nice because we're not going to have different symbols. We're not going to talk about sample median or population median. We're just going to tell you about the median, how to calculate the median. So the median is the middle of a data set written in order least to greatest. What we're going to call ascending order. So if you write all your data in order from least to greatest and find the middle value, it's called the median. Two ways to calculate it. So we'll do two different examples. So this one has an odd number of data values. They're written in order already, least to greatest, so we don't have to do that step. Does it have a middle value? Yeah, what is it? 3. So we find the middle one. So the median is 3. Got the same thing we did when we found the average, the mean. Right? So that's interesting when that happens. When they're exactly the same or close, then that's interesting to us. Okay. Now, what if we have an even number of values? Is there a middle number? No. If you had 6 fingers, you could not give someone the middle finger. It would be impossible. Okay? So what do we do instead? We find the middle 2 values. So in this case, it would be 3 and 4, and we find the average of those 2, or the mean of those 2. And if there's only 2, you also call it the midpoint. So, you know, what's halfway between them. So in this case, the median would be 3 plus 4 divided by 2, right? It's going to find what's halfway between 3 and 4. That's 7 over 2, or 3.5. So here our median is 3.5. And you can see 3.5 cuts the data right in half. Okay, so that's the intention of it, is to figure out the middle. And here, the 3 cuts it in a half if you take the 3 out. Right. So let's just describe these two things, these two methods. So I'll say if n is odd. Remember, n is the sample size. Okay, so we'll just do it for a sample. If n is odd, you first arrange data in ascending order. Arrange your data in least to greatest order. And then you just simply find the middle value. Find out where the middle is. And there's a trick to it. I'll show you the trick. The middle value is always in the n plus 1 over 2 position. So the middle value is always going to be in the n plus 1 divided by 2 position. So what does that mean? Our first data set has 5 members, right? 1, 2, 3, 4, 5. So n is 5, right? Sample size is 5. What's n plus 1? 6. 6 divided by 2? 3. The median is in the 3rd position. Not the median is 3, even though it was in this case. It means if you counted them, where would it occur? It occurs in the third position on this one. Okay? So let's try this with some other sample size. Let's say my sample size was 481. I had 481 in my sample. And I wrote them all in order. Where is the median going to be? So add 1 to it. So what's 481 plus 1? 482. Divide it by 2. 241. So I would go to the 241st value when they're written in order, and whatever that number is, that's my median. Okay? This is a little trick to help you figure out where that is. And then if n is even, same thing, arrange data in ascending order. Take the mean of the middle two values. So you have to find the middle two values. I got a trick for that too. So my trick for finding the middle two, we'll say the middle two values are always in the n over 2 and the next one. The next one would be n over 2 plus one more positions. So the middle two values are always in the n divided by 2 and the n divided by 2 plus 1, which is just the next one, positions. So my second example had 6 values, so n would be 6. So my middle two would be in the n over 2 position. So what's n over 2 if n is 6? What's 6 divided by 2? 3. And then what's n over 2 plus 1? 4, right. So 3 plus 1 would be 4. So my middle two would be in the third and fourth positions, and that's where they were, right? And they happen to be 3 and 4 as well, and we got 3.5. So let's do another example. Let's say I've got 1,000 members in my sample. So my sample size is 1,000. What's 1,000 divided by 2? 500. And the next one would be 501. So you'd find the 500th data value and the next one and average them together, and that'll be the median. You agree if you have 1,000, right, 500 would be the last one of the first half, and 501 would be the first one of the second half. That's what you're doing. You're taking the average of those two. Okay? Any questions about median? It's pretty easy, right? You just got to remember what to do if it's even or odd sample size. Mode? Mode is data value or values that occur most frequently and at least twice. So the mode is the data value or values that occur most frequently and at least twice. So you figure up how many times each data value occurs in your data set or in your sample or your population. And you find the frequency of each one, right? You could make a frequency table to figure this out. If you have one that has the highest frequency, it's the mode. If it occurs the most times in your data. If there is a tie, you can have more than one mode. So if there's a tie for the most frequent, then you just say you have 2 modes, or you have 3 modes, or you have 4 modes. You could have a lot of modes. If all of your data is different, if every data value is unique, and there's no repeats, then you do not have a mode. You say there's no mode. Or you say no mode exists. So, here's the data set. So I look for all my repeaters. I have 2 4s. I have 3 6s. I have 3 8s. So which one is the most frequent? 6 and 8. I have a tie. So both of them are the mode or modes. So say I have these modes. Okay, I have 2 of them. All right, I'm going to show you stack crunch steps. So I'm going to open up that car mileage data that we used last class, right? And I'm going to use let's use the model year. So stat menu, summary stats, columns. So stat menu, summary stats, columns. I'm going to pick year. I'm just going to choose the default. So I'll let it pick the default values here. So it gave me the mean, 2009.3636. So that's the average model year for me and my students, right, in statistics. And my median is 2009. So the mean and the median are pretty close. And that's going to be interesting to us. What isn't up here is the mode. So I can find the mode by just making a simple frequency table, right? We learned how to do this last class. I just made a frequency table. I didn't do any binning or anything. I just made a frequency table. And I look at the frequencies. So which ones are the highest? So 2009, 2013, and 2016, right? So those are my modes. Now, is there a function for mode in the summary stats calculator? Yes, there is. So I'm going to go back and see what that does. So I'm going to, instead of these, I'm just going to pick mode, see what it does. So what happened? Just tell me I got more than one, right? So if there's only one, it'll give you the value. If there's none, it'll say none exist. If you have multiple modes, it will not tell you what they are. It'll just say you got multiple ones. So too bad. But the frequency table is pretty easy to do. Just make a frequency table and see if you have multiple modes. But this mode function is not one that's defaulted in that summary stats calculator. So when I go to stats, summary stats columns, I have these statistics that are automatically chosen for me. They're highlighted. And if I want to add the mode, I can. I can hold down Control, and I can tag it onto the end. I got to pick a column. See that? I added mode to the end, but it's not one that's defaulted. And it's not one that I really like, because it doesn't really tell you if you have, it doesn't tell you what the modes are if you have multiple modes. So I don't really use it. I just use the frequency table. So now, question is, let me get this back up here. My question is, we have these three measures of center. Which one do we use? Which one's better? It depends on your data. Okay? So let's imagine this example. Let's imagine that we collected everyone's household income, put it in a data set, and we found the mean income and the median income. There probably would not be a mode. None of us would probably have the exact same income unless we rounded, unless we just kind of guessed. If we got the exact values, it probably not going to have any repeaters. So if I take the mean and median, probably going to be close to the same. They might not be, I don't know, but they'd probably be close. Okay. What if LeBron James walked in the room and we added his household income to our data set? What would happen? What would happen to the average, the mean? It would go way up. And we would probably have an average income of $1 million a year, right? So is that $1 million a year, is that a good representation of the typical salary or typical income in this classroom? No, right? It would still be a correct calculation of the mean. It wouldn't really represent what we're trying to get at if we're trying to get the typical income. What would happen to the median, though? LeBron James walked in and we added his salary, let's just say his income's $100 million a year, and we just added that to the top of our list, right? We write them least to greatest, we add it to the top. What happens to the median? It just moves up a little bit, right? It just moves up to the next value, or it's not going to move that much, right? So our median would still be a good representation of what a typical household income would be for the people in this room. Does that make sense? Let's look at it in this data set. Let's say that someone had a car that was made in 1925, and they were driving it. Okay, so I just added a really, really low value, right? What happens to the mean and median? So I'm going to put these next to each other, right? So what happened to the mean? It dropped, looks like about 2.5 years. Okay? What happens to the median? It actually stayed the same because there were so many, there were 4, remember there were 4 2009s, right? So when we added that extra value, it just moved to the next one. So the median didn't change that much, right? So we're going to say you should use the median when you have these extreme values, or what we call outliers. Okay? If you have outliers or extreme values, like LeBron James' salary in a classroom full of broke college students, right? If you have that situation, the median is going to be a better measure of the center. Okay? What about the mode? Well, like I said before, there may not even be a mode for salaries or household incomes. So, you know, the mode is not very good for quantitative data. But for something like qualitative data, let's say that I polled all of you and I got the state that you were born in, you know, what state or country maybe that you were born in, and I took that data in. I can't average all those up, right? I can't find the average birthplace, right? That doesn't make sense. I can't put them in a numerical order and find the middle. I can put them in alphabetical order, but that's not, and you find the middle of an alphabetical order, you haven't done anything, right? So alphabetical order and numerical order are 2 totally different things, right? So you can't put them in a numerical order, so you can't even find the mean and median for that kind of data set for something qualitative. But what you can do is you can count how many states and how many countries were in your data set, right? I can count how many times Tennessee pops up in my data, and if it's the most frequent, then I can say Tennessee is the mode. Does that make sense? So I can do that with quantitative data. I can actually use the mode for that when I can't use the other 2. But if I have quantitative data, I'm probably going to use the mean or the median. So let's write all that down. Which measure of center is the best? So it depends. The answer is it depends. But we're going to write out what I just said. So we're going to use the median when there are extreme values. So that could be extremely high or extremely low, or what we call outliers. So use the median when there are extreme values or outliers. I apologize for my handwriting. Use the median when there are extreme values or outliers, because the median is not susceptible to those. Use the mode for qualitative data. If you have qualitative data, you can use the mode. You can't use the other 2 at all. So that's the only one you got left. And then you're going to use the mean otherwise. We'll say otherwise. Let's just stop there. We'll say otherwise. If you have quantitative data and you're not going to use the median, then use the mean. The mean is the mean's going to be the one you're going to use the most. And in fact, you want to give, if you're doing a research project or research paper or you're reading research, you want the mean and median both together because you want to compare them. Okay, so a good statistical researcher is always going to give you both of those. You're not just going to pick one or the other. But if you're working for, say, CNN, and you gotta write a headline, are you going to use mean household income? Or are you going to use median household income? And you're probably going to use median for income because of the LeBron James of the world. So we say the median is resistant to extreme values. Or outliers. And the mean is not. The mean is very susceptible to those extreme values. So we have this word called resistant. And there are other things we can calculate that are resistant, but the first one we've learned is the median. So we like the median because of this. Any questions so far? Okay. So I want to show you, I have this data set. It is the entire roster of every World Cup team in the 2018 FIFA World Cup. So I have every player, I have their name, their team, their position, and a bunch of stuff, but I want to look at their weights in kilograms. So I'm going to make a histogram of the weights of these soccer players. And StatCrunch will let you put in these markers for the mean and median. So it's going to show us where the mean and median are in the histogram. And the mean is going to be green and the median is going to be red. So that's what it looks like. So what shape does this distribution have? Bell shape. It's symmetrical. It's bell shape. We also call it normal. And where is that mean and median? They're almost exactly in the middle. Okay? So if you have a bell-shaped or normal distribution, your mean and median are going to be really close, and they're going to be right in the middle of the data set. They're going to lie right in that largest frequency bar that goes up in the middle. Okay, so that's usually what happens when you have this normal distribution shape. Okay? In fact, we can hover over these and see what these are. So I've got a median of 77 and a mean of 77.2, right? So they're very close. And we expect that when the mean and median are, well, let me say that differently. When we have a normal distribution, we expect the mean and median to be very, very close. And we expect them to be right in the middle. Okay, I have another data set. This is California home prices from the year 2009, and it has the MLS number listing, location, the price, how many bedrooms, bathrooms. I want to look at the square footage. So the square footage of these houses, I'm going to make this same histogram. I'm going to mark the mean and median and just look at what it looks like. So what's the shape of this distribution? Skewed to the right. Okay? So skewed to the right means most of my data is on the left. So most of the square footages for these houses are between, 1,000 and 2,000 square feet. Do we agree? And what is skewing it? What is making this tail off to the right? These big, humongous houses, right? So I have some 6,000 and higher, and even some 5,000 and higher square footage homes, and they're not very frequent, right? The frequencies are very small. There's not many of them. But these are extreme values, we would say, right? They're not close to the 1,000, 2,000 range square footage homes. Do we agree? So those big values are like the LeBron James salaries, okay? And they're pulling the mean which direction? To the right. So this green line is the mean, and the red line is the median. So the green line has been pulled to the right. When we say it's skewed, what we're really talking about is the mean. The mean has been skewed to the right. And the median is about where it should be. It may be a little bit tilted in the right direction, but it's stuck about where we would expect it to be. But the mean has been pulled to the right. Does that make sense? So when your graph is skewed right, your mean will be pulled to the right. The median will stay about where it's supposed to be. Right? If we eliminated all of these really large houses, then the mean would go back closer to the median. Okay? So let me look at a different one. Let's look at just the MLS number. So they list these homes and they assign a number to them so you can look them up. It's like a case number, right? And they just keep going up sequentially. So the highest numbers are the most recent listings. Does that make sense? And the lowest numbers are the ones that were listed, what am I trying to say? The longest time has passed since they were listed. So there's not many of them, right? Because most of the houses listed around the 135,000 numbers were sold, right? Most of those are sold, and there's only a few that are left. So their frequencies are low. But that low number, right, is skewing the mean to the left, right? These low value listing numbers are skewing the average to the left. Does that make sense? I would expect the median to be right here on this tallest graph or close to it, this tallest frequency, and the mean has been pulled to the left of it. Okay? So if it's skewed left, your mean is going to be skewed to the left, okay, in relation to the median. So I want to write all that down. Let's call this distribution shapes with mean and median. Distribution shapes with mean and median. So if you have a normal distribution, your mean and median are going to be in the middle, and they're going to be really close to each other. So I'll just draw a little picture here. And I like the green and red thing. So my median should be really close to my mean, and they should be in the middle when you have normal distribution shape. If it's skewed left, if it's skewed to the left, those really, really small values, even though they're not very frequent, they're going to pull the mean to the left. So maybe my mean is here, my median is here. Man, I'm messing that up. My red's not working very well. Come on, red. Green works. Red is going nuts. Let's use black. So here my median would be over here. So the median would be greater than the mean. Right? Skewed right. Going to have the opposite thing happen. Yeah, red's messed up. Median will be about the same place it should be. But the mean will be pulled to the right. So the mean will be greater than the median. So I want you to open up that car mileage data set that I had open. So see if you can get back to it by yourself. If you need help, I'll help you. But see if you can get back to that car mileage data. So it's under your groups, right? Open StatCrunch, go to groups. I want you to find the mean and median and mode. See if you can get what I got when I did it earlier. Excuse me. I'm sorry. Nope. That's not the right group. So explore, groups, type in my last name, Willman.
Oh, it's
M-O-N. You got a M, M-O-N. There you go, M-O-N. There you go, O-N. There you go. First one, join, and then click that, yeah. It's the first one right there. So I want you to find the mean, median, and mode in StatCrunch and see if you can do it.